The combustion of 100 grams of butane with 100 grams of oxygen will produce how many grams of carbon dioxide and how much excess remains? Well, this is a gram to gram limiting reactant problem. When you're burning stuff, it's pretty amazing oftentimes how much oxygen is required. And for this one, for every 116 grams, that's 2 moles of butane, 2 times 58, where the 58 came from the 48 for the carbon and the 10 for the hydrogen, will require easily in excess of 300 grams of oxygen. Since even 10 moles would be 320 grams, we do not have enough oxygen. It is the limiting reactant, and I'd recommend that you only figure out how many grams of carbon dioxide will come from the grams of oxygen. I will show you both ways just for completeness. So there it is. We do believe oxygen is easily our limiting reactant, and we can do the longer but reliable method of checking out both of the substances that are reactants and seeing when you will run out of either of them. For the butane, 58 grams is a mole, and a mole of butane will make 4 moles of carbon dioxide. Those moles of carbon dioxide weigh 44 grams each. You will run out of butane after producing 303 grams of carbon dioxide. For the oxygen, I believe we will run out of it much sooner. Set up your 3 steps since it's a gram to gram conversion. Remember, we're going to grams of carbon dioxide. In this case, 32 grams is a mole, but every mole of oxygen will produce only 8 moles of carbon dioxide. Those are the numbers in front. See the 13 and the 8? It still has a mass of 44 grams, and we run out of oxygen after making only 85 grams of carbon dioxide, at which point the butane is just sitting there. So this reaction will only make 85 grams of carbon dioxide. If you're wondering how much remains, let's see how much the oxygen produced. So we'll go from the 100 grams of oxygen to grams of butane to see how much that needed. The rest will be excess. That's the logic for these types of problems. There it is written right there. 32 grams of oxygen is still a mole of oxygen. In this case, the 13 moles of oxygen will only require 2 moles of butane. See it right up there? What's its mass? Same units, top left to bottom right, is 58 grams per mole. The oxygen will consume 28 roughly grams of butane, and the remaining 72 or so grams of butane remains unconsumed.